Hi everyone, welcome back to Life Technologies YouTube channel, and thank you for watching and supporting this channel. So in our previous IPRAN training episodes, we've covered in details how to design the Interior Gateway Protocol IGP for IPRAN Network. Some key concepts that we covered in IGP design were why we need to deploy IGP on IPRAN network, which we mentioned that we need to have end-to-end connectivity. We need to have reachability all the way from the access side to the controllers, which are connected to the core nodes. We also discussed why we need to segment our network into different IGP processes, that is the access and aggregation processes, how to implement route import and export between the access and aggregation IGP processes to ensure that we have end-to-end connectivity. And we also discussed how to improve network security by implementing protocol authentication. And the final point of discussion was how to speed network convergence speed to ensure that we can reduce downtimes when network failure occurs. So one thing we know that service provider networks span regions. We could have the service provider network divided into different regions or divided into clusters for easy management and control of routing information. And each cluster could be having thousands or 10,000 of routing devices. So in total, a service provider network will have so many routing and switching devices that we need to ensure that we have reachability between them. So in one region or a cluster, we can use IGP as we have discussed before. And we can either use OSPF or SIS as our IGP within these regions, just to ensure that we have end-to-end connectivity. But these IGPs are not best suited for inter-cluster or inter-region communication. So we need to have a protocol that we can use that can give us control over the routing information between these clusters or the regions. And sometimes even remember that on IPRAN network, we are also using VPN. So we need a protocol that can be able to exchange these VPN routes between different sites or between different regions. So on our BGP design, these are some of the key concepts that we'll be covering. The first question is why we need to deploy BGP on IPRAN network. As I've mentioned, IGP protocols are not best suited for inter-region or inter-cluster communications. They won't give us the flexibility to control how traffic flows between these regions. And many times you find that these clusters or regions are multi-homed to other regions. So we need a protocol that gives us the flexibility and the power to control traffic flow between these regions or clusters. Another reason why we need BGP is we are using MPLS VPN on our network. So we need a protocol that we can use to exchange the VPN routes on our network. So BGP will give us the control that we need, and it's also scalable compared to the IGPs like SIS and OSPF. So if we are deploying BGP on our network, we have the concept of autonomous systems. So we need to have autonomous system numbers that we are configuring on these regions or the clusters. So which AS numbers do we use on IPRAN? Many times, remember, IPRAN network doesn't connect directly to the internet. We have the core network that acts as intermediary between the IPRAN network and the internet. So on IPRAN network, we normally use the private AS numbers. And if you remember well, the private AS numbers ranges from 64512 to 65535. So those are the AS number that we'll be using on the IPRAN network. Then we can now peer to the core network. The core network can now use the public AS number to peer with the external networks. Then another thing that we'll be discussing is how to control traffic flow using BGP Path Attributes. Remember, BGP has so many path attributes that gives us the flexibility and the power to control traffic flow on the network. So we can deploy or we can use these BGP path attributes to control the traffic flow between different regions or clusters. Another thing that we need to focus on is which BGP architecture to use. So on IPRAN network, we have two main architectures. We have the HVPN or HoVPN. So this one is mainly decides the route advertisements between the aggregation and the access nodes. So you can either use the HVPN or HoVPN. And later we'll discuss in detail the two architectures and even do a lab simulation on the same. When we are doing a peering between clusters, we also need to decide which option, the BGP in the IS option that we are using. Are we using option A? Are we using option B or option C? So of course option A is always the easiest, the VRF to VRF peering. So in this implementation, we'll also simulate how to do option A, option B, or option C, so that you have a good understanding of how to implement these options on IPRAN network. Because remember, IPRAN network, apart from peering between regions, will also be peering to other networks, the core network that will now connect us to the internet. Another thing that we need to focus on is, should we use Meshed BGP peering, route reflectors, or BGP Confederation? Remember, BGP has different mechanisms to control loops. So we have the split horizon. In case you have deployed iBGP in your network, then you need to come up with a mechanism to ensure that all routers can get the routing information. So we have Meshed BGP peering, route reflectors, or BGP confederations. In our implementation, we'll be using mainly the route reflectors to ensure that, it's the iBGP neighbors can all learn the routes from the route reflector. Then the same way we did for ISIS, we also have to deploy BGP authentication on the network to ensure network security. And then there are also mechanisms that we can use to speed BGP convergence speed. So these are just some key concepts that we'll be discussing in this BGP implementation on IPRAN series. So as you can see, we have this topology here, and we've tried to show how different regions will be connecting to other regions. So when you have a network that is divided into different regions, it's always nice to have multi-homing, like you have two connections to other clusters, so that you have 2 or 3 exits from one cluster, so that if we have failure on one path, the traffic can be able to switch to the other path. So that is the objective of having multi-homed clusters. And you need to assign an AS to each cluster, and then we'll be doing eBGP between the clusters. Within the cluster, we also do iBGP. Why? Because remember, as I mentioned before, we need to do route exchange for the VPN routes. So we need iBGP to be able to exchange the routes between the VPN routes within the network. So within the cluster, we'll be doing iBGP peering. And then between the different clusters, we'll be doing eBGP peering, just to ensure that we have end-to-end connectivity. So each cluster will be assigned an AS number, the autonomous system. Remember, an autonomous system is just a network that is under one administration or one organization. So in our scenario, network within one region or one cluster, we assign an autonomous system so that it's separate from the other clusters or regions. So once we've deployed iBGP within the cluster, we'll do eBGP between the clusters using the different AS numbers. And I've already mentioned that we will be using private AS numbers for the IPRAN BGP implementation. So remember, these are the concepts that we need to discuss going forward. we'll be doing lab simulations and demonstrating how you can implement all these BGP concepts on the IPRAN network. Thank you for watching, and please remember to comment, to like and subscribe to our channel for more upcoming videos. Thank you.